Okay, now I'm recording already. Okay, I'm recording. All right. So turn off. Right. Okay, let's continue. So yesterday, this period. Okay. We stopped at period. All right. Turn. Yeah. So for period, there is two formula. Okay. One for simple pendulum, another one for mass spring system. Okay. So for simple pendulum, the formula is if you look at actually these two formula almost the same. Is period equal to 2 pi square root 1 L over G, or for that is for simple pendulum L over G. Is mass spring system is M over K. And also we know that one more thing, we know that period is equal to 1 over frequency. So we also can write the formula as 1 over frequency equal to 2 pi square root L over G, or we also can write as 1 okay, you know, period is equal to like this, M over K. Second, M over K. So if you look at simple pendulum, does not depend on mass. Depend on mass. So independent of mass, but it depends on length and gravity. So we can predict that longer simple pendulum has longer period and lower frequency. Okay, and if you have lower gravity, if you lower gravity, then you have longer period, smaller frequency, like that lah. Lower gravity, like let's say like the moon, you will have longer period. On the moon compared to the earth. On the moon, lower gravity, you will the simple pendulum will oscillate slower, the frequency lower. Okay. The angle theta must be small. This theta, there is conditions here. The conditions for simple pendulum must be, the theta must be small. It means this theta here. The angle of oscillation here. This theta must be small. Must be less than 10 degree. If more than 10 degree, then it does not obey simple harmonic motion. And then the string must be inelastic and light. The string must be inelastic. You cannot use something like rubber band or what. Must be inelastic, and only gravitational force and tension in a string acting on the simple pendulum. No other friction or what. Only the gravity and the tension in the string. Okay. And for mass spring system, you can say if the mass is bigger, let's say it's a heavier mass, then longer period, lower frequency. That means it oscillates slower Okay. If you have a smaller k means that means the spring, this is K is the stiffness of the spring. If the spring is like soft spring has lower K. Lower K, then it oscillate slower, longer period, lower frequency. Soft spring lah. If hard spring, then it oscillate very fast. Then this period will be lower and then frequency will be higher. If what I mean is if hard spring, then shorter period, higher frequency. The other way around lah. Okay. And one more thing here, you can let me see, everybody's here. All right. Okay, everybody's here already. Good. Now one more thing is does not depend on parameters of motion like amplitude. It does not depend on. What does it mean here? Not depend on amplitude. That means for both actually. This one also independent of last time, independent of mass and also amplitude. Do you see? Simple pendulum independent of amplitude. The mass spring also independent of amplitude. What does it mean here? One more. If you look at pendulum independent of mass, but mass spring system depend on mass. So there's some difference between simple pendulum and mass spring. Simple pendulum does not depend on mass, but mass spring depend on mass lah. Okay, depend on mass. Okay, but the similarity between these two, they independent of amplitude. Simple pendulum independent of amplitude. Mass spring is also independent of amplitude. What does it mean here? That means if you look at the formula here, this period you cannot see amplitude. Dia tak ada formula macam apa? Dia tak ada formula macam period equal to 2 pi A. Suddenly got amplitude there. Yeah, tak ada. Yeah, dia tak ada amplitude. So it does not depend on amplitude. Yeah, what I mean is, macam mana cakap dia independent of amplitude? That means if my oscillation, okay, okay, this is the equilibrium, okay, I oscillate, I put with this much amplitude, okay, but the other pendulum I put with very high amplitude, yeah, very high amplitude, okay. So you can see A2 is much higher, A1 is smaller. So I want to ask you, what's the difference between their period 1 and period 2? Which one do you think will take longer time to oscillate? Which one will take longer time to oscillate? Yeah? Same thing goes to the mass spring system. Mass spring system, how to draw? Okay, this is the equilibrium. Let's say for one spring, the amplitude is this much. The other one is very high. Yeah, very high amplitude. Okay, so I want to ask you, which one take longer time to oscillate? Yeah, what is this? Excuse me. Okay, which one will oscillate? Wait, which one will take longer time to oscillate? Which one? Period 1 or period 2? Maybe some of you will say, oh, of course, the one travel longer distance will have longer period. The one with smaller amplitude, shorter period. No, you cannot say like that. Okay? They are independent of amplitude. Independent of amplitude, that means they have the same period. They have the same period. Although the A2 is bigger than A1. They have the same period. They still have the same period. Although A2 is bigger than A1. Okay? So it's independent. The period, so I can also say when period is the same, frequency also same lah. They have the same frequency. Okay, same period means same frequency because period is 1 over f. When period is constant, frequency also constant. So the independent of amplitude, you go to the di taman permainan, kamu suka main buaian yang with big amplitude sebab lebih seronok. But if you compare the period between the longer amplitude with the shorter amplitude, they have the same period. They oscillate the same rate. I can say they oscillate same rate. Sama cepat, yeah. They have the same period, same frequency. Okay, class, do you understand? Yeah. So same goes to the spring mass system. They have the same period, same frequency also, even though they have different amplitude. Different amplitude, but they have the same period, same frequency. Okay, so that's all for for simple harmonic motion. So now let's go to solve some questions. Yeah, do I just want to check whether I record the video? Okay, I record it smoothly. Good, So independent of amplitude, but in terms of energy, in terms of total energy. Of course, the total energy for when amplitude bigger, the total energy for is bigger lah. Because total energy formula, it depends on half m omega square amplitude square, isn't it? In terms of total energy, the total energy for E2 is bigger than E1 lah. This one E2 bigger than E1. Okay, in terms of total energy, the second one has more energy compared to the first one, but they have the same period. Okay, why total energy different? Because total energy depend on amplitude. The bigger the bigger the amplitude, the more the total energy of the system. Of course, if you look at this spring mass system, the more amplitude means more compression. More compression means more elastic energy, more elastic potential energy stored in the spring. So the more elastic potential energy stored in the spring will be converted to more kinetic energy in the block. Convert to more kinetic energy of the block. So the total energy, of course, bigger if you have bigger amplitude. Okay, if you like this one, go higher a bit, so it has higher gravitational potential energy, higher mgh, compared to smaller amplitude, lower mgh. Bigger amplitude means more mgh. More mgh means it will convert to higher kinetic energy of the pendulum also when the pendulum reach the bottom. Okay, all right, so many explanation. Okay, so let's go to solve the question for tutorial. Okay, so this is chapter 7, oscillation. So there are many questions until question 9, I see. Until question 9. I wonder today how many questions we're going to do. So let's do one by one. Okay, so I already transfer here the questions. Okay, anyway, we actually don't be afraid, because we actually just going to use this formula here. We are going to use this formula here. All this formula, we're going to use this formula only. The displacement, velocity, acceleration formula with time, with displacement, velocity with displacement, acceleration with displacement, and then the kinetic energy, potential energy, total energy formula. So this formula, and then maximum for each displacement, velocity, acceleration, a omega square. So you're going to use this table. This is the summary, the most important summary. Okay, so look at the first question. So this is a displacement. So you first thing you must check, this is displacement. About displacement, so this is a displacement time graph. Okay, displacement time graph. So definitely, okay, what is the equation for displacement? First thing I want to ask you, what's the equation for displacement? Equation for displacement is a sine omega t, isn't it, class? Let's check. Y equal to a sine omega t. That's right. It's a sine graph. Is it a sine graph? Yes, it's a sine graph. You see that, class? It's a sine graph. And so this, the maximum is the a lah, or negative a. Understand? And the value here, you see, this is the period, and this is 2 period. Check the unit. This is in cm. This is in second. So that means all this amplitude in cm. All this amplitude in cm. So must be careful. And then the period is in second. So okay lah. Period in second. Okay, so you are given the mass here, m. You have mass here attached to one end of the horizontal spring, the other end is fixed. So this is a displacement time graph, oscillate in simple harmonic motion. Determine equation of the displacement as a function of time. So I want equation. So let's do it. Question A. So equation of displacement versus as a function of time. So I want equation yt equation. So it is y equal to the general formula first. A sine omega t. A sine omega t. All right. So how to find A? I know is A is 1.8 cm lah. A is 1.8 centimeter. Okay, A is 1.8 centimeter. And then what about omega? I cannot find omega, but I have the period. The period. So remember the formula for omega is 2 pi over period. 2 pi over period, right? So just put in the period, which is 0.2 second. 0.2 second. So what do you get, class? I need some helper. So, okay, what's the... Let's check. You can maintain in fraction form. Maintain the pi. You can maintain the pi. So, 2 divided by 0.2 is 10, right? So this is 10 pi radian per second. 10 pi. Okay. So, right. So the formula is y equal to 1.8 sine 10 pi t. So that's it, class. That's it. And you must write the unit. Don't just give the formula like that. You must write the unit because your 1.8 is in cm, not meter. So you must write here the unit where y in cm, t in second. Why t in second? Why the time in second? Because our here is time is in second. So our period in second. Our period is in second, so time in second. But our y displacement is in cm. So you must write y in cm. The amplitude also in cm. Yeah. When your amplitude is in cm, so when your amplitude is in cm, so your displacement also will be in cm. Okay. When your omega is in per second, so your time will be in second. Because they cancel off, centimeter with centimeters per second. Okay, so remember when you write the formula, you must have the unit also. You must write where y in cm, t in second. Okay. Now B, velocity and acceleration of the oscillation at any time t. So he want the equation also. He want the equation for velocity versus time, acceleration versus time. Okay, so let's do it. Okay. Remember I taught you how to differentiate. Velocity versus time. Velocity is dy over dt. Okay, and then for acceleration versus time is you dv over dt. You differentiate the velocity. Okay, let's do the v first. Differentiate. Okay, if you want to differentiate, or you just use the formula okay, but if you want to differentiate, I can show you also. Yeah. Okay, I show you. Before I show you the differentiate, why don't just use the formula first? So formula given, you see, formula is omega cos omega t lah. Just use this formula, just substitute. Yeah. Just put it a omega cos omega t. Understand, class? I think, yeah. A omega cos omega t. That's right. Yeah. A omega cos omega t. So I no need to show you how to differentiate lah. Yeah. Because to get this formula also is a result of differentiation, right? So you just substitute the A. What is A? 1.8. 1.8. Wait, I want to check the unit is in, the answer is in meter or cm. Let me check first. Yeah. So let's check the answer. Is it in meter or cm? So we just follow lah. Yeah, we just follow. So oscillation. Okay, change to meter. All right. So better change to SI unit lah. Yeah, class. Change to SI unit. So displacement in meter. So you must change to meter. So better. If not, susah nanti. So better change to meter. So how to change to meter? This amplitude is 0 divided by 100, so it's 0.018 meter. So change it. So okay, so next, y equal to 0.018. Okay, because now it's in meter already, sine 10 pi t. That means your amplitude now is in meter, your displacement will be also in meter. Yeah, your displacement also in meter. So you must write the unit also, where y in meter, t in second. Okay, so that's the answer, isn't it? 10 pi t sine. Correct lah. 0.018. Correct. Yeah, that's right. In meter, better change to SI unit lah. Always change to SI unit. Now, to find the velocity time, okay, velocity time. So everything in SI unit already. So later our velocity unit must be in meter per second lah, meter per second. So no worry for that. So okay, so let's do it. First we find the Vmax. The Vmax is actually the A omega lah, isn't it? The front part here, that's our Vmax, A omega. So 0.018 multiply 10 pi. Our omega is 10 pi, isn't it? So we get 0.18 pi. 0.18 times 10. Okay. That's unit in meter per second. Meter per second. Velocity. Okay, so that's our equation here. 0.18 pi. 0.18 pi. Cos omega is just now. Omega maintain 10 pi. Okay. So that's our equation, and then you must write the unit where what? V in meter per second in SI unit, because I already changed the, because I just now changed the amplitude to meter already, isn't it? So now everything in SI unit lah. So save for us. Here the time in second. Okay, that's it. And then the next one is about the acceleration time. Acceleration time. So let's do our acceleration time. So how? Acceleration time. Okay, acceleration time. Just check the formula. Acceleration time formula what? Acceleration time formula is negative omega square A sine omega t. Yeah, just use this formula. Okay, acceleration equal to negative A omega square sine omega t. Correct or not? Yeah, omega square A. I always like to write A omega square. Got negative A omega square sine omega t. Correct lah? Okay. Then you have to find the acceleration maximum. Our acceleration maximum is A omega square. You understand, class? This just now you have Y maximum also. This one is Y maximum. Y maximum is A. See that? Y maximum is A. Y maximum is A. That's why you get here, yeah, A. Y maximum is A. V maximum is A omega, which is this, the front part here. And then acceleration maximum is A omega square, which is A omega square here. Understand, class? Yeah. So like this one lah. This one. This Y maximum, V maximum, A maximum. The front part. Okay. Okay. So I got that. So it's a negative sign graph. Okay. So now calculate lah. Do calculation. Yeah. Time is ticking, so I have to fast, And omega is 10 pi square. So this one I have to calculate. I need some help actually, yeah. So 10 actually become 100, right? 100 018 0.018 times 100, which is 1.8 pi square, isn't it, class? Yeah. So just put it there. A equal to negative 1.8 pi square sine omega is 10 pi, right? So you must write there where just now the unit I haven't write. Unit is meter per second square because I already changed to SI unit, where A in meter per second square and time in second. Okay, so that's the answer lah. The three formula: displacement, velocity, acceleration formula. Okay, let's check the answer. Let's check the answer. Is it correct, class? Yeah. Oh, here. See that? So y is 0.0 sine 10 pi t, correct? Velocity 0.18 pi cos omega t, correct? And acceleration is negative 1.8 pi square sine omega t, correct? Yeah. And always write the always write this class. I want you to write this always write the unit even though the answer don't show it, but I want you to write this where, because sometimes this one got marks. Okay, now good. We solve it. Yeah. This formula you can differentiate lah. Actually, you can differentiate from this formula to get this velocity formula. Displacement differentiate to get velocity, and then velocity differentiate you get acceleration. How do you differentiate? I already showed you last time, yesterday. So you can differentiate by yourself later on. But if you want to be quick, you just use the formula given, yeah. Because this formula will be given also in the list of formula, yeah. You can do the differentiation, yeah. Now, maximum speed. See, maximum speed and magnitude of acceleration of the oscillation. So he want the maximum speed. We already got it just now, isn't it? We already got it. So maximum speed is this one lah. C, this one, maximum speed. Yeah, this is the maximum speed. And acceleration, maximum acceleration. This one lah. Maximum acceleration, this one. Okay, maybe he want in value, right? Not sure he want. Maybe he want in value. Let me check. Yeah, one in value. Yes, one in value. V max, A max. So let's find in value. Yeah. So this one will be equal to the V maximum equal to 0.18 times pi, which is okay. So it's 0.565 meter per second. How about this one? Acceleration 1.8 times pi square. So 17.77. Yeah, 17.77. Okay. Meter per second square. Okay, let's check the answer. So let's check the answer. Yes, it's correct. 0.565 meter per second, correct. And then acceleration maximum is 17.8 or 17.77 meter per second square, correct. Okay, correct. That's it lah. A omega square and A omega. Okay, so total energy of the system. I want to find total energy of the system. What's the formula again? Total energy. Total energy formula, half m omega square A square. Use this formula only and then calculate lah. Total energy. It depends on amplitude. So D. So total energy formula is half m omega square amplitude square. It depends on total energy depend on amplitude. the bigger the amplitude, the more the total energy lah, right? So mass, just now mass given. Mass is given 0.18, sorry, 0.85. 0.85, so just put in 0.85. 0.85, omega is 10 pi kan? Omega is 10 pi square, and then amplitude is amplitude is changed to SI unit, meter, 0.018 meter square. Don't forget the square, don't forget the square. So what do I get? 0.1018 square times 10 pi square times 0.85 divided by 2. So I got the total energy is 0.136 joule. Is it correct, class? 0.136? Is it correct? Yes, total energy is 0.14 joule or 0.136 lah. Yeah, 0.136 or 0.14 joule. Okay, so you got it. You got it. 0.136, 0.14 joule. Correct. Okay, that's for question 1. Is it very hard, class? Is it very super hard? I don't think so, right? Just use the displacement formula, you know, find the omega, find the amplitude. You must understand the diagram. You must understand this is amplitude, this is period. See the unit, everything. Check the unit, convert to SI unit. And then, you know, use the velocity formula, acceleration formula, find the Vmax, Amax, you know. And then the total energy, use the formula also. Not hard, not difficult. You can do it. Okay, question 2. In an engine, 200-gram piston oscillate in simple harmonic motion with displacement varying according to this. Okay, now class, you see, class, this is a past year question, past year, but actually our syllabus changed. You see, the displacement formula now is using cos instead of sine, right? Our syllabus actually use displacement, use sine, sine. So actually this question won't come out anymore. Yeah, according to the syllabus, according to syllabus, the displacement must be a sine equation. Must be a sine equation. Okay. So the question, the exam will only come up with question using displacement equation, sine equation. So there won't be displacement equation in cos. Kalau displacement in cos, that means dia bukan sine graph sudah, dia guna cos graph sudah. So actually this question won't come out anymore because our syllabus changed already. Yeah, since 2000, I don't remember which year, but our syllabus changed because now it's 2024. This is already 8 years before, right? 8 years before. This now is 2024, so it's quite long ago. Yeah, this question is quite long ago, but I can show you how to do it also. Yeah, no problem. Okay, I can show you how to do it. But remember, this question is actually out of syllabus. Yeah, this question is actually out of syllabus. But it's also good to know how to solve if, let's say, your displacement equation is using cos. Understand? Okay. So OOS means out of syllabus lah. Okay. Okay. Mass given 200 gram. So displacement equation. Okay. So I want you to write here displacement equation. Displacement equation is 5 cos 2t. This is the formula given. This is the formula given. So the general formula for this is a cos omega t. Is using a cos omega t instead of our formula using, where is it? our formula is A sin omega t. But this formula different a bit. You use A cos omega t. Okay? So how to do it? No worry. But you must know how to differentiate. You must know how to differentiate. Yeah, if you want to find, let's say, like velocity equation, want to find acceleration equation, then you must know how to differentiate. Pembezaan. Yeah? And the y is in meter. Okay, y is in meter and t is in second. So all in SI unit lah. Yeah, no worry. Yeah, all in SI unit. So that means your m, when he say y in meter, t in second, that means my y in meter, that means my amplitude also in meter. When t in second, that means my omega is per second lah. My omega is per second. Yeah. So my amplitude is in meter also. Now, write an expression for velocity with time. Okay, see that? You want the velocity equation. So that means you must know how to differentiate. Okay, so how to do, class? Very simple. Yeah. But if you don't know differentiation, then it's difficult lah. Kalau you tak tahu differentiate, memang difficult lah. Okay. Velocity is dy over dt. Okay, dy over dt. So to differentiate this, that means I differentiate, remember, I always differentiate outside, then I differentiate inside. Do you understand what I'm talking about? Differentiate outside, then you differentiate inside. Differentiate outside, 5, you differentiate 5 with versus time. Differentiate 5 versus time. 5 is a constant. So constant memang tak ubah lah. Dia memang dikekalkan. So 5 itu dikekalkan. Differentiate cos, you get negative sign. You get differentiate cos, you get negative sign. Understand, class? And then the inside here maintain. You maintain first. And then you differentiate inside. You bezakan dalam, differentiate inside, you get differentiate versus t. Differentiate versus t, that means t itu macam 1 tolak 1 bah. 1 tolak 1 jadi kosong lah kan. So hilang sudah t itu, so tinggal 2. Differentiate, differentiate 2t, we get 2. Differentiate 2t, we get 2. Kamu faham gak ini? Kalau tak faham, nanti kita you jumpa saya lah, ya. Don't want to spend so much time on this. Just if you tak faham tentang differentiation, you can ask your friend, ask me later. Okay. So differentiate cos, you get negative sign. Differentiate 2t, you get 2. Yeah, but I believe you are quite a good students from your background for SPM, so your mathematics tambahan should be okay lah, ya. So that's why I don't explain banyak. Okay, differentiate cos, you get negative sign, so then 2t, you get 2 multiplied to the front, you get negative 10. So that's the formula for velocity. Okay, so you got already the equation. So where V in meter per second, T in second. Memang semua dalam SI unit lah, sebab dulu pun memang dia dalam meter dan second kan. So dia kekal meter per second dan second lah. Okay, so I got the equation. So question B, sketch the graph velocity versus time graph for first complete circle. First complete circle ni, okay, dia nak one complete circle saja, ya. Dia nak graph velocity versus time graph. Velocity versus time graph. That means according to this formula lah. According to this, this formula, this expression. So let's draw it. Yeah, question B. Velocity. Okay, this is a velocity meter. You must write meter per second, and then must write unit Mesti ada simbol dan unit. You tak boleh hanya You tak boleh hanya apa? Begini je. Kalau begini salah. Kalau begini salah ya. You must write the unit also. Must have unit also. Okay? Okay, so it's a negative sign graph. Yeah? Velocity is a negative sign graph. So draw lah negative sign graph. Negative sign graph means kalau sign graph begini, kalau negative sign graph terbalik lah. Terbalik. Negative sign graph. Tapi dia nak one complete cycle saja. Dia tak. So you just one complete cycle. So just one period sahaja. Faham tak? Satu period sahaja. Jangan dua period. You must follow the instruction. Okay? Kalau dia kata two complete circle, then baru you lukis lagi satu. Faham tak? Sekarang dia nak one complete circle saja. So you just tulis one period saja. Understand? Okay. So dan of course ini mestilah A omega. Kalau V maximum kan, ini negatif A omega. Kalau ini ialah A omega, ini ialah negatif A omega. A omega itu apa? Itulah. This is the A omega class. Kan? Ini kan kita tadi kelas inilah A omega, inilah V max, inilah A omega which is 10. Kan tadi kita apa? Kita tadi 5 ini amplitude kan? Ini kan A dan ini kan omega kan? Betul tak? Omega. So omega darab ke depan, inilah A omega. That is the A omega. So 10. So this is 10. You must write there 10. 10. And then this is here you must label negative 10. Okay? Negative 10. Period is what? Period. Kena cari period. So period kena cari. So that means itu period cari dari mana? Cari dari omega. Cari dari omega. So omega kan 2. Betul tak? Kan omega itu 2. See, omega is 2. Omega is 2. So omega, what is formula for omega? Formula for omega is 2 pi over period. 2 pi over period. So cut off. So period is apa? Apa dia? Pi lah, betul tak? Period is pi, isn't it? Period pergi atas. Period kalau pergi atas tinggal pi lah kan? Kalau period pergi atas tinggal pi. So period is pi second. So this one you can label as pi. Understand? Atau saya tulis beginilah, period ialah pi di sini. Okay? Kalau ini velocity graph, sudah selesai. Kalau you nak, dulu kita punya displacement graph, dia macam mana? Kalau displacement graph, tengok equation ini. Displacement graph dia adalah begini. Displacement graph, dia tak minta, tapi saya lukis untuk kamu. Supaya you tahu. Okay? So displacement graph is a cost graph. So you draw a cross graph. Dia nak satu period saja. So satu period saja, satu period. So the period is the same. Understand? The period adalah sama. Displacement graph, velocity graph, period dia sama. Sebab dia share the same omega. Mereka mempunyai omega yang sama. Omega dia sama. So cuma ini ialah A, displacement kan amplitude. A ialah maximum kan. So ini A. Ya. A dia ialah apa? A dia ialah apa? 5. Amplitude dia 5. Okay, ini negatif 5 di sini bawah. Ya, ini kosong. Ini kosong. So itulah. This is the graph for displacement, a cost graph, and then velocity graph is a negative sign graph. Okay, understand? Okay, let's continue. Don't waste our time. Ya, sekejap je tengok. Saya ingat boleh 9 soalan. Tapi sekarang sudah 8:47. Baru 2 soalan pun tak sampai. Okay, so question C. Let's do question C. Maximum acceleration. A maximum ialah apa formula dia? A omega square kan? A omega square. So A omega square that means apa? Tadi kan kita sudah kira A omega kan? Kan tadi saya dah kira A omega kan kita ialah 10 kan? 10 darab lagi omega. Omega kan kita ialah 2. Omega kita 2. Omega ialah 2. So ialah 20. A maximum kita ialah 20 meter per second square. Nak lukis graf untuk acceleration lagi. Acceleration tak payahlah ya. Kamu sendiri differentiate ya. Maybe the question, let's say question E lah. Question E. Ask you to draw acceleration time. Acceleration time graph. Tahu lukis tak? So you kena buat equation dulu. Acceleration apa ya. Lepas tu lukis graf dia. Kalau sekali tengoklah. Dia adalah graf apa? Acceleration kena differentiate velocity lah. Kalau differentiate velocity, dia akan jadi apa? Differentiate guna velocity equation. Differentiate you get differentiate sign you get cos. Tapi negatif itu maintain. So dia dapat negatif 10 cos 2t. Understand? Differentiate sign you get cos. Negatif masih ada. Negatif 10 itu tak ubah. Negatif 10 tak ubah. Hanya differentiate sign you get cos. Differentiate inside you get the 2. You get tinggal 2. So 2 tu darab ke depan. So dia jadi negatif 20 cos 2t. Apa akhirnya saya buat juga. Sebab saya apa tu? Terlalu nak ajar lah. Itu saja sebab ya, because I nak sangat nak ajar ya. Takut kamu tak tahu. Itu saja ya. Saya takut you tak tahu saja. So time second. So ini negative cos graph. Negative cos graph is a inverted cos graph lah. Inverted cos graph. So ini akan jadi 20. Negatif 20. Faham tak? Because maximum dia 20 kan. Ini period dia masih pi. Betul tak? Period dia masih pi. Period masih pi. So that is the displacement graph is a cos graph, velocity is a negative sign graph, and acceleration is a negative cos graph. Bagi soalan inilah, soalan ini di mana y dia adalah cos equation instead of sin equation. Ya, kita selalu sin omega t, ini guna cos omega t. So benda-benda ini semua graph semua berubah. Velocity punya equation berubah. Acceleration punya equation pun berubah. Graph semua pun berubah. Understand? Graph semua belum berubah. Yeah? So you must be careful. This type of question. Question C, maximum acceleration. Kita sudah cari kan tadi. Maximum acceleration kan ini. Maximum acceleration. Kita sudah cari tadi kan. Oh, what is this? Yalah. Maximum acceleration 20. We got it. 20 kan? Ini 20. Is 2 darab ke depan. 20 lah, correct lah. This is in fact what I'm showing you just now. This one is A omega square lah. This is the A maximum. Understand, class? It's the A maximum. Okay, what's the total energy, class? The total energy of the system. So D. What's the formula again, class? By now, no need to refer. I already memorized in my brain. Memorize. Yeah, of course lah, you can Google everything, no need to memorize. But sometimes to make life easier, just memorize. So half m just check. You see, this formula lah. Total energy half m omega square a square. So okay, so what's the mass? Let's check back the mass. Mass is 200 gram. Be careful with the unit, class. Gram. This is gram, not. You must change to kilogram. So mass is 0.2 kilogram. Don't go to blindly put in 200. So 0.2 instead of 200. So 0.2. 0.2 omega is what? Omega is 2 square, and then amplitude is what? Amplitude, start from the beginning, amplitude is 5 meter. Yeah, y in meter. So amplitude is 5. Amplitude is 5. So let's calculate class. 0.2 multiply 2 square multiply 5 square, and then divide by 2. So what? I get 10. I get 10 joule. Okay? 10 joule. Okay, let's check the answer. Let's check the answer. Yeah. Let's check the answer. Is it correct, class? Our velocity equation. Yeah, question A, velocity equation negative 10 sine 2t. Correct lah? Tengok, V equal to negative 10 sine 2t. It's a negative sine graph. Negative sine graph, sine 2t. B is a graph lah, graph question, but not shown lah. Yeah. Only in the answer scheme. Okay. Only this one lah. This is the graph, negative sine graph. Okay, so negative 10 sine 2t. Correct. Acceleration maximum is 20. Acceleration maximum 20. Betul lah. 20 meter per second square. Total energy is 10 joule. 10 joule. Correct lah, class. Kan? Class, is it very, very difficult? Is it impossible to do it? The answer is not impossible, right? Nothing is impossible. So, kalau you tahu dia punya konsep, senang je. Okay. So, question 3. Kejap je lah. So, let's look at this question. So, displacement time. This is a displacement time graph. Displacement time graph. So, this is a, you see, displacement time. Unit. Check the unit. Sometimes in cm. Be careful. This one is in meter. Okay lah. This one in second. Okay. Kalau sometimes it can be millisecond here. It can be cm here. Just want to make your life miserable, you know. Just want to trick you lah. Yeah. So be careful. All this unit. So amplitude. Okay, what's the amplitude? This is the displacement time graph. Displacement time. Displacement time graph. So ini memang amplitude dia. Di sini kalau sini negative amplitude, sini akan dapat negatif 2 sebenarnya. Negatif 2. So amplitude ialah question A. Amplitude is 2 meter. Lagipun unit dia meter di sini. So and then angular frequency. Angular frequency lah apa? Omega lah. Ya, dulu kita panggil angular velocity. Angular velocity. Sekarang dia panggil angular frequency. Sama saja, ya. So macam mana cari omega? Omega kena kira 2πo period. Period di mana cari? Inilah period dia. Inilah period. Kan? Satu gelombang ialah satu period. Lagi satu gelombang. Ini jadi 2 period. Faham tak? Lagi satu gelombang. Ini jadi 2 period. So 5 second. Period is 5 second. So is 2π/5. I think can maintain the answer in fraction form. So the answer is radian per second. Okay. And then for maximum speed, V maximum. V maximum is apa formula dia? A omega, kan? Tengok ini. Nah, di sini Y maximum is A. Y maximum amplitude, V maximum A omega. A maximum ialah A omega square. Yeah. Okay, so A omega, V maximum, A omega. So A omega, so is omega A kita ada 2. Omega kita berapa? 2π/5. So berapa kita? So ialah 4π/5. Itulah dia jawapannya. Meter per second square. Itulah jawapannya. 4π/5. Deduce expression for the motion. Senang sangat kan soalan ni? Expression of this motion. So dia nak equation lah. Ini maksudnya dia nak equation. Boleh? Equation. So this is a y versus t equation. Y versus T punya graph. So this is a Y equal to, dia adalah sine graph kan? Betul tak? Dia sine graph kan? So dia punya equation pun sine lah. Follow our general formula. Memang dari dulu kita belajar kita punya Y displacement formula adalah sine A sin omega T. So ikut tu saja. Lagipun graph pun sine. Graph pun sine. Kecuali tadi punya soalan graph displacement dia adalah cos. Itu lain cerita lah kalau cos graph. Kena lukis A cos omega T lah. Tapi kita punya, you tahu tak kita punya kenapa kita punya sine kelas? Kenapa kita punya displacement punya sine? Sebab kita punya displacement equation, kita refer to the y component. Y component ni ialah A sin omega T, bukan A cos omega T. Kalau A cos omega T, sebenarnya dia ada X component. You tahu tak kelas? Kalau dia guna, ini kena tukar simbol. Kalau dia guna cos, it must use A cos omega T, must use X instead of Y. So if you use cos equation, then this one cannot write Y anymore. You must write X actually. It refer to the X component. Refer to the X component already instead of Y component. So our syllabus will stick to the Y component. So that's why we use sine equation. Understand? Not cos equation. But in general, if you look at international books, some of it use the X component. So they use cos equation. Some they use cos equation because they use X component instead of our metric syllabus. Our metric syllabus use the Y component. That's why we use the sine omega T, yeah, not the cos omega T. Okay, so I hope you are clear for this. Okay, so okay, I'll go back to this one. Yeah, so A sine omega T. So Y is equal to, our A is 2. Then sine omega, our omega just now we calculate 2 pi over 5. 2 pi over 5 T. So and then you must write what? Apa yang saya minta tulis juga? Saya minta tulis unit. You must write where Y in meter. Kenapa kita kata Y in meter? Sebab graph dia memang dalam meter. T in second. Second. Okay, tengok formula, tengok jawapan. So soalan 3, betul lah, 2 meter. Oh, dia dalam nilai, dia dalam nilai. Cuba kira lah nilai kalau boleh. Kira nilai dia juga. So actually kalau bagi dalam fraction pun, kami tak tolak markah, kami dapat markah penuh juga. Tapi kalau you rasa tak selamat, kamu tulis dua-dua lah. Tulis fraction dan juga nilai, ya. Tulis fraction dan juga nilai. Faham tak? Kalau rasa tak selamat, tulislah dua-dua. So 1.26 radian per second. And then this one is 4 pi divided by 5. So I get what? 2.51 meter per second square. Okay? So, betul tak? Betul. You see? 1.26 radian per second, 2.51 meter per second. Oh, this is V maximum. Sorry. Salah unit. Ini meter per second. It's not acceleration. Dia velocity saja, bukan acceleration. So, salah unit, hilang markah. Itu saja, senang cerita. Salah unit, hilang markah. So apa pengajaran? Be careful, Saya tak mau you hilang markah macam itu. Okay? So meter per second. Okay, then the equation for the displacement 2 sine 0.4. Begini pun boleh, 0.4 is 2 divided by 5 is 0.4 also lah kan? 4 times 5 is 20 kan? Ya. 0.4 pi T. Correct lah. Correct, ya. Okay. Just question 3 only, ya. Question 4. Okay lah, never mind lah. So I think class So far so good, class. So far so good. Understand So begitulah ya, tak susah sebenarnya. So after this you boleh try lah, tapi saya pun akan bincang juga soalan ni. Nanti pun saya akan bincang. Tapi nanti esok Isnin, Selasa, Rabu saya akan continue with chapter 8 dulu. Sebab chapter 8 kita belum siap pula ya. Chapter 8 kita belum siap. Tapi I already touch, but in the amali, in the practical session later, I will continue with chapter 9 lah. So for this week, tutorial session, I will continue chapter 8. For the amali, I will continue with chapter 9. Amali, I continue with chapter 9. Okay, I think that's good lah. So everybody okay class? So not so hard kan? This chapter 7. What I say chapter 6, chapter 7 kan? Yalah. It's not hard lah. This chapter is logic lah. Ya? Things is not so difficult ya. So you maybe tengok balik video ni lah kalau tak faham ya. Tengok balik video kalau tak faham. Okay, so itu saja. Thank you So kita continue esok lah. Kita continue esok dalam kelas. Alright. Thank you. Good night.
Thank you, sir.
Okay.
Good night, sir. Thank you, sir.
Okay, thank you.
Thank you, sir.
Okay, thank you.